Hello, everyone. Welcome to BSidesSF 2023. My next presenter is Armen. Today, Slido is not working. We will be doing live Q&A at the end if we have time. If not, we will be doing it in the lobby. Go ahead and take it away.
So this is a 10,000-foot view of what was happening in those previous slides. So first, a user attempted to access something behind Okta. Then Okta recognized that the user needed to authenticate against our custom identity provider. And Okta routes to our custom identity provider using IDP routing or IDP discovery. Our identity provider validates the device and then indicates to Okta that authentication was successful. And from there, Okta proceeds with the authentication flow, prompting the user for their FIDO2 key, and an Okta session gets established. Apologies in advance, as this slide is going to be pretty Okta specific. For those that are trying to implement something device trust related within Okta, there are three options you can consider. First, you can use the native Okta device trust solutions. There's a variety of options in Classic and in OIE. You can purchase a third-party vendor for a device trust solution, and you can build your own. And so when exploring the different vendor-centric options, one thing that became really apparent was most vendors try to integrate with Okta using an external identity provider. And this was a little confusing at first, but after doing a little bit of research, it became really apparent as to why this was. It's because there's no real other way of integrating with Okta to be able to do something like this. And so if you're trying to do something interesting, if you're trying to modify the authentication flow in some capacity, you're really left with no other choice but to build your own identity provider, literally take the user out of the Okta ecosystem, do your interesting thing like device trust, and send the user back to Okta. And so once you have that identity provider, there's two different ways of integrating with Okta. You have IDP as MFA, which allows for a customer to replace their existing form of MFA with the device trust identity provider. And you have IDP as SSO, which allows customers to replace your Okta password with the device trust identity provider. However, at the expense of introducing multiple methods of bypassing the external IDP. So for Pinterest, because we have this more complicated MFA policy, if you will, because of our FIDO2 deployment, using the IDP as MFA approach was never an option for us. And so what we've done is basically use the IDP as SSO approach. And if you're interested in how we mitigate all of these bypasses that I'm referencing, I'll be linking to a blog post at the end of the presentation, so feel free to check it out. All right. So we have basically concluded that in order to do that interesting thing, we need to build our own identity provider. And so now the question becomes, what do we do with that identity provider? How do we determine whether or not a managed device is being used to authenticate? And so there were three things that were top of mind when we were figuring out how to do this. First, we wanted to have an intuitive user experience for our end users. We didn't want to dramatically change how authentication looked or felt. We didn't want applications or users to have to switch between apps or something like that to determine if a managed device was being used. We wanted something that was platform agnostic. We wanted to support all of the existing platforms that we support at Pinterest today, which includes macOS, Windows, Android, and iOS. And we wanted to do this in a way that didn't require the use of any new agents. We didn't want to write our own iOS or Android apps to support this. And so what we landed on was a certificate-centric approach to do device attestation. So we use certificates that are only provisioned to managed Pinterest devices as a means of authenticating devices that are being used to authenticate to our identity provider. So let's go a little bit deeper into the actual authentication flows that we support within our identity provider. So we have a passwordless flow, which most of our employees use to authenticate to Okta. And we have a 3FA flow, which is used when authentication is necessary from a shared device. So for the passwordless flow, you'll notice that once the user is in our identity provider, the user presents a certificate that includes both the user and device contexts. We validate whether the certificate itself was valid, and then we extract the device metadata from that certificate and ensure that the device associated with the certificate is in a compliant state. And if all of that is true, we give Okta the thumbs up and basically say, proceed with the authentication, I have authenticated the user, and that's where Okta takes over the authentication flow, prompts the user for their FIDO2 key, and an Okta session gets established. For the 3FA flow, it's a little bit more complicated. For this particular flow, you might notice that there's an authentication flow within an authentication, and that's why we call it the exhibit flow. So the reason why this is necessary is because we want to be able to support shared devices, and we also want a pathway for having a higher bar for authentication. Think of admin accounts or something like that. And so there was a desire to introduce 3 factors. And the way that we go about doing that is essentially triggering another authentication flow when the user is in our identity provider. And so if you think of it in the context of an outer authentication flow and an inner authentication flow, for the outer authentication flow, it resembles what you see above really closely, and the inner authentication flow happens and needs to be successful in order to complete that outer authentication flow. And so this is how we can get around one of the limitations within Okta, which is that you can only enforce 2 forms of authentication. So I may have lied a little bit when I alluded to the fact that mutual TLS or certificate auth results in a positive user experience. In fact, browser-based mutual TLS often leads to a horrendous experience for end users, as demonstrated in this slide. So notice that within a native application on Android, after canceling the certificate prompt, there's no intuitive way for the user to recover from that mistake, even going as far as restarting the application or refreshing the page. You're not able to be re-prompted for that certificate prompt. And so in order for us to move forward with a custom identity provider that uses certificate-based authentication as its primary form of auth, we had to solve this problem. And I'll explain how we mitigated this issue in the next few slides. So the thing responsible for this behavior is a Chromium cache called the SSL client auth cache. This is responsible for caching the decision that a user makes when they're greeted with that certificate prompt. And so the most notable thing to take away from this is the entries in this cache are based on the host port pair associated with the server or host name that you're trying to interact with. And so if we keep that in mind and we make some server-side changes to maybe abuse that functionality or how that cache works, we're able to trick the browser into thinking that they're continuously seeing a new host name. And so the way that we go about doing this is really simple. We just continuously redirect users to random subdomains. And so this is what this looks like in production, again, in a native application on Android. And notice this time around, when a user is prompted for that certificate prompt, canceling does not result in that super painful experience. And in fact, I think this is a pretty intuitive way for the user to recover from that mistake. And this is the actual representation of the routing logic in our edge infrastructure. And so notice up top that if a valid client certificate isn't presented, we perform a 302, sending the user to a random subdomain. And if at that point a valid certificate isn't presented, then we'll present the user with that error message with a button to try to re-authenticate. All right. So we have reached the point where we've built our own identity provider. We have now also determined which device is trying to authenticate based off of the certificate that was presented. Now we get to talk about how we do device attestation or device health attestation. And so the first thing that we do is at authentication time, we collect all of the data, all of the device data associated with the device trying to authenticate. And so we collect data from our log aggregation tool, our EDR solution, our MDM solution, OS query, and really anything else in our environment that might contain relevant information regarding the compliance state of a particular device. From there, we take that raw data and we run the devices through all of the compliance policies that exist. And so each one of these compliance policies can result in a pass or fail. And if there are no policy failures, the authentication flow proceeds transparently. The user doesn't know anything about what happened in the background. But if there are some compliance failures, depending on the severity of the issue, depending on the policy itself, we'll either block authentication outright, or we'll present a user with a series of warnings and give the user the ability to proceed with the authentication flow. And so this is an example of what an actual compliance policy looks like. And so what I'll draw your attention to is on the third or fourth line, you'll notice that the action configured for this policy is block. So if there's a failure, we'll block the authentication. And if you notice towards the bottom, we're taking some OS query data that indicates whether SIP is enabled or disabled on a device. And so depending on the data that we get back from OS query, we'll evaluate this policy as failing or passing. A couple of other things that might be relevant here is there are several different sources that can be incorporated into a compliance policy. So if we want to create a compliance policy that incorporates data from OS query or our MDM solution or our EDR solution all within one policy, that's something that we can do. All right, my favorite slide. So one of the issues that we've run into, both with our FIDO2 initiative as well as mutual TLS, has been related to compatibility issues with native applications. And so what we found is 99% of the time, if we're unable to get mutual TLS to work, or we're unable to get FIDO2 to work, the root cause has been the use of web views in native applications. And so a web view is incapable of accessing the keychain that contains the certificate on your device. And a web view also doesn't have access to the APIs necessary to authenticate someone with FIDO2. And so this is, if you're an app developer, the only embedded browsers or libraries that you should be using within a native application are up on the screen here. And so on Android, you should be using a Chrome custom tab. And on iOS, you should be using one of the three that are listed up there. And so if there are any app developers in the room, I would please ask that you stop using web views, particularly for federated auth, where you're trying to authenticate a user against an external identity provider like Okta or OneLogin or Google or something like that. And if you're interested in looking at a list of compiled applications that we know are not compatible with FIDO2 and mutual TLS, or if you're interested in adding to that list, please visit fido.fail. And with that, I will open it up for questions. Thank you for your time. All right. go ahead.
Okay, we have about 5 minutes for questions. Coming around. It's getting recorded, so if you could use the microphone. Thank you.
Hello. So, I guess 2 questions. I also am implementing Okta for my company. And what is your OIDC provider based off of? Is it like an open framework, or did you guys build it from scratch, your custom IDP?
So we built it from scratch.
Oh, fun. So what is the underlying flow for mTLS support?
So there isn't actually any sort of mTLS support in the identity provider itself. The way that this works is we handle the TLS termination on our edge infrastructure within Envoy.
Okay.
And the service itself is basically an OIDC provider with no authentication. And so this is more of a Pinterest infrastructure specific thing. But the way that this works is the OIDC provider is basically relying on our edge infrastructure, Envoy, to validate the integrity of the certificate before routing to our service.
Okay, so I guess that goes down to my second question. How do you distribute the certs and make sure that the cert is only tied to a specific device?
Yeah, so for certificate provisioning, in our environment, we only provision certificates to devices that are enrolled in our MDM. And so for us, MDM enrollment equals managed device.
Okay. Yeah. Okay. Have you looked at proof of possession tokens?
No.
Okay. Yeah.
Do I have any more questions? Hands? Sorry, I can't see the front side. Coming.
Are you doing anything that's in particularly targeted at session hijacking, or is that covered by like other security things that you went over earlier?
So for session hijacking, the way that we address that specifically is not directly related to device trust and how we're doing this. The way that we address that is by requiring a FIDO2 prompt for every application access attempt. And so, yeah. For FIDO2, yeah. Yeah.
Okay, we have 3 more minutes for questions.
Have you recorded any metrics of the success of like improving your device compliance since instituting this system, and can you share?
So in terms of the compliance checking piece, admittedly that has been deployed not too long ago. So I want to say less than 6 weeks ago, and we've started out with only a handful of policies, and so there isn't enough data right now to really demonstrate how presenting users with warnings is actually affecting the compliance state. There was a moment on the second week where it looked like we had like 40% less compliance failures, and then it spiked up the next week. So I would say at this point, it's a bit too early for us to say as it relates to like presenting warnings to users for compliance failures. Yeah.
Any further questions coming?
Just to follow up, why Okta? You got your own OIDC provider. It's just for SAML and apps?
This is a spicy question.
Yeah.
I don't know if I should answer that question, but I think at the end of the day, it's not entirely in my control.
Oh,
and so we don't actually own, from the security perspective, the security team doesn't actually own Okta, and it would be very difficult to move off of Okta, I think. Yeah.
Okay, that will be our last question. Any further questions can be asked in the lobby, but I would just like to say on behalf of BSidesSF and our sponsor, gift sponsor, Doyensek, that we thank you for being here today.
Thank you so much.
And thank you all.
Yeah, thanks everyone.